Good morning, everyone. Thanks for joining us. We're going to wait for the audience to arrive. Good morning if you've just joined. Thanks for coming, and we're going to wait just a few more seconds until the bulk of the audience is here. And hello, this is Leah Freeberg from Fluke Reliability, and thanks for joining us for this Best Practices webinar. You probably know Fluke as a test tools provider, and you may also know that we produce some of the industry's favorite reliability tools, from infrared cameras to vibration meters. But you may not know that many of the measurements that our tools collect now flow automatically into EAM systems of record. It happens via a framework that we call Fluke Connect. Our goal at Fluke Reliability is to better connect asset management data and teams with asset management systems to drive connected knowledge. And of course, that knowledge depends greatly on best practices in condition-based maintenance. So that's why this series of webinars explores reliability maintenance strategies. And that's why we feature speakers from a variety of expert backgrounds. Before the presentation, we have a few housekeeping items to go over. Today's session is being recorded, so your phone lines will be muted to minimize background noise. However, we will be answering questions both during the presentation and afterwards. So take a minute now to find the questions tool in the GoToWebinar dashboard. Please feel welcome to submit questions as we go, and I will share as many of them as time allows for our presenters to answer. We will also be using the chat tool during today's presentation. So if you see that in your dashboard, have a look there as well. If we have unanswered questions at the end, we'll do our best to follow up with written answers. And if you'd like to receive the slides from today's presentation, please let us know during the survey that will appear at the end of today's session. So don't hang up until the survey appears and you've answered the questions. We're also happy to send you a certificate of attendance after today's webinar. You'll see a question on the survey about getting a certificate. Answer yes, and we'll send one to you. Lastly, a recording of this webinar in full will be available on the excelix.com website within a day or two. So that's it for the housekeeping items, and now for the main event. Today, we are very pleased to have with us Mike Smith, a veteran reliability engineer, consultant, and trainer. He'll be presenting on how to build a game plan to proactively manage your assets. Mike is a reliability engineering subject matter expert at Lifecycle Engineering with more than 30 years experience. Before joining LCE, Mike worked as an engineer and maintenance manager in the pharmaceutical, fabrication, chemical, and metal forming industries with companies such as Michelin North America, Georgia Pacific, Eaton Electric, and Johnson & Johnson. He has used lean manufacturing principles and process excellent methodologies to increase performance in a variety of industries. Mike has been recognized for impacting the bottom line by increasing plant availability, speed of production, cost reduction, and quality performance, all the things that we all look for. He holds a Bachelor of Science degree with honors in electrical engineering from the University of Tennessee. Welcome, Mike, and thanks for being with us today.
Well, thank you for having me. It's good to be here. I'm looking forward to talking with everyone today.
Indeed. So I'm very curious, and I have to ask, where did the idea for the game plan approach to asset management come from?
Well, when I was first asked to talk with Fluke, it was right in the middle of the time with all the issues associated with the COVID-19 virus, whether or not we're going to have football seasons. As many of y'all know, that's been a lot in the news lately. And it just kind of popped in my head, how much reliability and football actually are very similar in how you organize it. And so that's why I came up with that subject.
I am very intrigued. So why don't we get started?
Okay, thank you very much. Well, first, let me tell you a little bit about Lifecycle Engineering. It is a consulting company based primarily out of Charleston, South Carolina. However, we have offices throughout the country. We are based in two separate divisions. One is an organization that is heavily involved in the military, specifically the Navy. And then we have our commercial services group, which is part of what I am. And it's broken down into what we call our Atlas by LCE, and that is a software system that utilizes over 40 years of knowledge that we have brought together of intellectual property and put it in a manner that we feel is very useful for people going through and trying to implement reliability within their organization. Then we have our Lifecycle Excellence group, which is basically looks at engineering and services as well as consulting to try to lead changes within an organization so that not only do you make an engineering decision or make an improvement in the process, but actually how do you take that and utilize the change necessary in the human being to actually make it a successful change. Unfortunately, most of us are engineers. So, sometimes we engineers tend to miss the human side of things. And that's a lot of what Lifecycle Excellence is about. Then we have a training institute that we call the Lifecycle Institute, and it focuses on formal operational maintenance management types of training, specifically around reliability and maintenance practices. So such things as reliability engineering, reliability excellence for management, things like that. Any questions? If not, let's get going. So what I want you guys to do is kind of first chat in who is your favorite football team. I want to get an idea who is in the audience.
So find the chat tool on your dashboard, should be a little gray bar. And I'm seeing some already. Saints, Roll Tide, Alabama, Browns, Go Gators, New York Jets, Pittsburgh Steelers, I can't keep up, Patriots, Crimson Tide, Seattle Seahawks, MSU, Chicago Bears, St. Louis Battlehawks, Colts, Go Pack Go, Go Gators, Cowboys, Dolphins, South African rugby team, nice, Springboks, Memphis Tigers, Miami Dolphins, don't watch football, just fine, Detroit Lions, LAFC Soccer Club, the Patriots, New York Football Giants, the Vikings, Texas A&M, River Plate, Argentina, Eagles, Steelers, Jets, Texans, Go Vols, Baltimore Ravens, University of Maryland, Carolina Panthers, Roll Tide, Iowa Hawkeyes, and Chicago Bears, El Ali Panthers, Virginia Tech Hokies. Dang, you guys, well done. The Chiefs, Marion Giants. Okay.
Okay, thank you, everyone.
Georgia Bulldogs, Patriots, 49ers. It's going to keep going, Mike. So I think back to you.
Okay, so we got a pretty broad group of folks out there. Well, I'll tell you a little bit about myself. I'm a Tennessee graduate, so I was born and raised in a room decorated orange. I married a beautiful woman from the University of Georgia, who her grandfather was the team doctor for Georgia for over 40 years. So I actually have to go to the Georgia banquets where they pass out scholarships and give one in his name. And I live in Clemson, South Carolina. So I'm all surrounded by football. Okay. So first thing I'd like to do is let's do a poll. I want to get a little bit of an understanding about where do you consider your reliability program? Are you reactive in that you're still doing a lot of, fix it when it breaks? Are you emerging where you're starting to utilize some, different types of tools, a little bit better processes? Are you being proactive where you're focusing solely on driving risk out of the business? And ultimately, are you a world-class organization? So Leah, if you could
Yep.
the poll, I would appreciate it.
You folks should have the ability now to use your mouse, your clicker, and select an option. If you cannot click a button, you may need to reduce the size of your screen. If its screen's maximized, it may interfere with your ability to click a choice. And obviously, we're limiting you to just one choice. You probably use a range, so pick the one that is the most representative. And I'm going to try to get, I'll encourage about 3/4 of us to select the most representative option. And again, so Mike has an idea of who's here and what state people are at. And this is awesome. I've got about 75% of the votes in. I'm going to wait just another couple of seconds. And it looks like we're at a good spot. So now I'm going to share the results. 18% say reactive, 50% say mostly emerging, 29% say mostly proactive, and 3% world-class sites. What do you think, Mike?
Well, that's that's pretty much a distribution. I'm very happy to hear that we have some world-class organizations. That's fantastic.
Mm-hmm. Yep.
But it's again a question of where you are and where do you need to take your organization and drive it to get better. Because if you
Indeed.
think about it, that's what we're all about, right? Is improving how we handle our assets.
Continuous improvement. I'm going to
Yes.
hide these results and give the screen back to you, but I want to encourage the audience to ask questions as we go. I have license to interrupt Mike at any time. So ask your best questions, and I'm gonna let him present. You won't get cheated there, but we will be asking questions or taking questions as we go today. All right, back to you, Mike.
Very good. Thank you. Can everyone see my screen where it says RE and DC responsibilities? Is that clear to you, Leah?
Yep.
Okay, very good. So what I contrasted is a reliability engineer and a defensive coordinator in a football team. And what we'll talk a little bit about is the similar types of thought processes that they use as they go through and structure their defense to prevent failures or to prevent the other team from scoring. You know, if we think about a reliability engineer, key member of the plant leadership team, right? That's an individual who has to have direct relational control or relational input to plant managers, directors, etc. His job is ultimately to define systems to prevent failure. You know, I understand that I really it's designed systems to prevent failure and the risk associated with it. Because there are some failures that don't provide risk and we don't spend a whole lot of time worrying about them. But if it's truly something that's going to have a negative impact to the organization, we need to make sure we're attacking it correctly. They determine that plan of attack, you know, and they utilize a defense in depth approach. And we're going to talk about that as we go through this. They study failure modes. They utilize FMEAs to understand failure modes and the risks associated with them. They also use root cause analysis to understand how failures have occurred so that we can put our corrective and preventive actions in place to prevent it from happening, to mitigate the impact, whatever the right situation is. But we define those corrective actions because we're focusing on the performance of the asset and how to make it better. Now, if you contrast that to a defensive coordinator, obviously a key member of the team leadership, they define the systems that are put in place in the game to prevent scoring. They determine the plan of attack for each opponent. They utilize a defense in depth approach. And if you think about it, a football team's defense is defense in depth. You have linemen, linebackers, defensive backs. They study the opponent's offense, just like an RE studies the asset failure modes. Little bit different that they used film as opposed to tools like FMEAs and things like that. and they determine the improvements needed to get better throughout the season. So if you look, there's an awful lot of similarities in defining a reliability program and defining a football program. And as I got to thinking about this, it really kind of made sense to me. A reliability engineer has to have some very key management partnerships, just like a defensive coordinator. He obviously has to be involved with maintenance, materials management, your work management systems, production and operations, the design function and procurement. Well, also, doesn't a defensive coordinator depend on things like the offense to maintain the ball so that the defense is not on the field much or limited, that the kicking teams don't make mistakes and put them with their back to the wall, that the offense and the skill players on the offense don't turn the ball over in such a manner that they have difficult positions. So if you think about it, you're each developing partnerships in different part of a team, an RE in a plant team, a defensive coordinator on a football team. But they're using the same types of skill sets.
Okay, Mike, I got a question for you. Two,
Yes.
actually. All right, back up a little bit. So far we're using a lot of plant language. Would you say that this logic applies to a variety of facilities and teams and asset management?
Yes, it does. As a matter of fact, I have a plant background. That's where my experience lies, so I tend to talk in the terms of plants. But, if it's matter of fact, one of the organizations I'm working with is a municipality.
Uh-huh.
Their water systems, their electrical distribution systems, things like that, steam heating, all fall into the same criteria, because an asset management system is really just that.
Uh-huh.
Whether it's in a plant, whether it's a municipality, whether it's a pipeline pumping natural gas across the country.
Okay. And the second question is about sort of where the RE fits. Who should they report to in the organization to be most effective?
Well, it really depends on the organization. What is really important, not necessarily who they report to, but who they have the ability to influence. They need to be able to influence the plant managers and the direct staff of the plant managers. In many cases, that means they report to the plant manager, but in some instances, they'll report to an engineering organization or a maintenance organization, depending. But they've got to have access to the top person to influence them, because that's what they're really trying to do. And that slide I showed just a moment ago about the interdependent partnering, that's really how you drive influence.
Uh-huh.
So it's really about how do you influence management and leadership. Okay.
All right.
I hope that answered the question.
I think it did. Carry on.
Okay. So obviously, in case y'all didn't know, there's a federal law that says every presentation has to at least have one continuous improvement circle or a triangle in it. Okay. So this is to meet the federal guidelines. I have a continuous improvement.
I think you're making that up.
I got to throw a joke every once in a while. But if you think about it, in the plan, do, check, adjust, or act, there's a couple of things that a reliability person needs to focus on. As you're developing your plan, which is your game plan, if you will, you're looking at analyzing the equipment and the assets that you've got for how critical they are to the organization. Failure mode and effect, understanding the impact of the failures and what the risks are, and then defining asset management plans on how you are going to prevent, predict, mitigate, whatever, how you're going to take care of this asset. And like I say, I tend to talk in terms of plants, but it could be municipalities, it could be pipelines, etc. It's how do you manage those assets and whatever the role of the company is. Then under the do, You implement maintenance plans. You implement predictive tools. Now, Leah mentioned some that Fluke uses, or not uses, but manufactures. They do infrared cameras. They do vibration equipment. They have interconnect systems for these. That's the do part of this, is implementing those tools and systems. And then finally, optimizing your PMs. So when we send someone out to do a preventive or predictive inspection, that they are utilizing good procedures and processes. Now for the check part of it, you utilize your CMMS, your computerized maintenance management system, and the RE is responsible for identifying repeat failure issues. We also use root cause analysis, and that is our feedback term for understanding what has happened and how we're going to prevent it. And then the ACT is those corrective and preventive measures that come out of both the root cause analysis and repeat failure analysis. So as you can see, it's a continuous improvement. Well, guess what? Football team does the same thing. We're not going to go into it as in depth, but it's all about continuous improvement and trying to set up our systems so that we are effective with that. You know, in football, you got to understand your opponent. What are their skill sets? What do they do good? Do they run the ball? Do they pass the ball? Whatever. But in reliability, we need to function on what are the functional failures and what is the risk and impact of those. So there's a couple of terms that I think that everyone in reliability should understand, and I'm going to use them throughout this discussion, so I kind of wanted to broach them. First is reliability. And I look at reliability as, you know, that asset or device or system does what I expect it to do when I expect it to do it. Now, that's not exactly the textbook answer, but the easiest way to understand it is, why did I buy it? Now, who here has a Ferrari? Anybody got a Ferrari?
I'm
Why did
not
you buy a
seeing
Ferrari?
any raised hands about Ferraris.
I didn't think there would be. But people buy a
I got a
Ferrari to
Porsche.
go fast and
There's
look
a
good.
Porsche.
Okay, we got a Porsche. Well, same thing. You buy a Porsche to go fast, look good, right? Well, I drive a 2003 Chevy pickup truck with 400,000 miles on it. You'll outrun me until I have to go down into the trout streams where I take the old fire roads through the mountains to get down to a trout stream. Your Porsche can't go there. My truck can. And there's no way any Porsche is ever going to make me look good. So it's just kind of stuck. So it's what you bought it for and what your needs are. And that's the goal of reliability, is to perform that function of what you purchased it for and what your expectations are for. Now,
And to get
functional failure.
400,000 miles on it.
Do what now?
And to get 400,000 miles on it.
Well, it looks like it's got 400,000 miles. So therefore, if I hit a tree while I'm down there, it really doesn't bother me a whole lot. I have hit a few trees and rocks too. Now, functional failure is the inability of that asset to meet that performance standard. Now, who wants to drive a Porsche that only can go 40 miles an hour? I have to have a truck that will get me down into those trout streams and back up. There are two different expectations. And when it fails to do that, if my truck leaves me down in the trout stream, I got a long way to walk out. Something I really don't want to do. So we have to understand the impact of that failure. If my failure were to occur in my driveway, it's probably not that big a deal. So we have to understand that. We also have to understand, how does equipment fail? Now, I'm a lot older than most everyone on this, and I will tell you that when I learned reliability and maintenance, it was the bathtub curve. Whenever you put a new piece of equipment, you had high infantile mortality. It was bad out of the box. We didn't install it right. something to that effect. And then it ran fine until, and I'm going to use my Southern vernacular, it done wore out. At which point you did a replacement or an overhaul. Generally, that was on a 3 to 5 year planned action. Well, as we've learned, there's not a whole lot of equipment that really follows the bathtub curve. Now, there are some, but it's not as common. What we find is that more often than not, the equipment still has the high infantile failure, but it goes into a random mode. In other words, we have to understand the condition of our equipment to identify that random mode. Again, we talked a little bit about what some of the equipment that Fluke uses: infrared cameras, vibration analysis, things like that are trying to understand the condition of our equipment so that we can identify pending failures while we're in that random mode. But as a reliability person, we still have to focus on the infantile failure and the random failure. It's kind of a twofold impact. So if you would, how about chatting in a couple of ways that you think we can reduce infantile failure in our assets?
So go ahead and write directly to Mike here, and you can use your chat tool, you can use your questions tool, but of the right out of the gate failures you've experienced with your assets, what's most common? So I'm seeing some answers here, Mike. So proper installation, no defined installation practices, poor work instructions, vibration analysis, laser alignment, pre-installation inspection, bad design, making sure the equipment is right for the application, good one. Use standards of installation and tolerance, again. FMEA, commissioning, proper commissioning, training, low bid,
Low bid.
nice.
I love that one.
Nice. Lab testing, installation practices, loose bolts, double check your installation, lack of training, good one. Design issues, lubrication, good design again during the selection. No plan, that covers a lot of, a lot of I think we could go on here, but
It sounds
yeah.
like it. And did you notice in what Leah was saying as she was reading out those chats, a very high percentage of those have to do with human error.
Indeed.
Unfortunately, a large part of the issues with infantile failure are human related. So some of the things that we need to do, and I heard some of those in there, was having good procedures, properly trained craftsmen, precise maintenance practices, such as proper torquing of bolts, alignment, things like that, proper lubrication of the equipment as you start it up, having good design practices. I can't help you a whole lot with low bid. Unfortunately, we're all kind of stuck with that. But we have to initiate defining those. Now, as a reliability person, we have responsibility to take those, set up our organizations and our processes within those organizations to try to mitigate that. Well, since we're talking about football, doesn't the coach, the defensive coordinator, spend a great deal of time developing and training his team to perform the jobs that they have to do and do them properly? There's a lot of correlation between the two. Football team deals with people, reliability folks deal with people. So I think most of y'all have probably seen the PF curve, but I like to look at it from a defense in depth standpoint. If we take an example, we suddenly have something becomes misaligned. Well, you have your linemen, followed by your linebackers and your safeties. Well, I saw that some of y'all were Alabama fans, and I really feel sorry for y'all about that. But I think Nick Saban would be happy if his linemen were making tackles. Of course he would. Because the earlier that you can impact the other team and take them out of their issues, their strengths, the better chance you have of stopping and getting the ball back. Well, as a result, football teams use linemen. Then behind them are linebackers. Their job is to, anytime something breaks through the line, they're responsible. And then finally, if the linebackers are not able to stop it, you have safeties in the back. Now, if a safety misses a tackle, you got a bad day. Well, so how does that impact from a reliability standpoint? You know, we have acoustical emissions that you can pick up things several months in advance. Vibration analysis, several months in advance. Oil analysis, looking for the quality of the oil, impurities, wear, debris, things like that. Whoops, got ahead of myself. But those first three are your linemen. You're looking months out in advance in these when you see things. Therefore, you're really trying to stop it at the line of scrimmage. Now, if you don't capture the pending failure in one of these types of defenses, the next step is your linebackers, infrared, your thermal variance. It's not as quick as some of the other types of systems. You don't have as much warning. But if you're still in the linebacking phase, you're still going to win the ball game, and you're still going to have time to effect a proper response to the pending failure, i.e. you're going to monitor it, fix it, whatever the appropriate thing is. Then you have the safeties. Now, where your safeties are, those are generally your operational and maintenance inspections, your PMs, if you will. Those that are using the senses or maybe some minor testing tools, things like that. You know, you have a little bit of time once you detect audible noise, but unfortunately, in my experience, it's usually not a whole lot of time. But by the time you can physically touch it, you better be planning on replacing it now. And the idea is utilize your linemen. If your linemen are successful, you're going to win the game. If your linebackers are successful, you're going to win the game. But you also have to provide the training and the skill set to your craftsmen and your operators such that if our predictive tools do not identify it, these guys have really got to be the, you know, they're the last defense, if you will. And what we don't want to ever happen is to get to the point where we actually fail to achieve what we purchased that vehicle from. You know, I bought my truck for the purposes of going trout fishing. I don't want to be left down in a creek. And certainly, we don't want to get to the point where we actually have a catastrophic failure. So again, it's defense in depth. Predictive tools, infrared analysis, operational and maintenance PMs, inspections, linemen, linebackers, and safeties. It's a fairly easy way to explain as you're going forward and trying to explain what you're doing to those who may not fully understand the concepts. It helps to show them.
I'm going to say mostly at this point, it's a lot of comments, Mike, that like, this is the best PF curve ever. And pretty impressive that you've got both football and a Chevy truck in the mix.
Well, anybody that likes to trout fish, come on, we'll go trout fishing.
Nice. Well, looks like you got another poll for us here.
Yes, if you would launch that, I would appreciate it. Thank you, Leah.
All right, there you go. Why don't you walk us through?
Okay, so some of the defensive positions, what strategies do you currently use within your organization? You know, acoustical emissions or vibration, human inspections, oil analysis, thermal imaging. That's just a few, but which of those do you guys use?
And what do you mean by tribology?
Oil analysis. That could
Okay.
be, where you take an oil sample and you're looking for wear particles, you're looking for conditions, you're looking for contaminants, etc.
Okay. Just making sure.
Yes, sorry about that. I hate people that use too big of words for what's needed. So I hate
We've
it when
got
I do it.
no worries. So you've
Got it.
got about almost 70% of the votes in.
Okay.
And folks, you can select more than one here. So finish up your thinking and give
Just
us your
check all the,
votes.
put a check by all of them that your organization utilizes.
Mm-hmm, mm-hmm. All right, I'm going to share the results now. 53% are using acoustical or vibration and or 81% human inspections, 34% tribology, and 49% thermal imaging.
Okay. So we have a pretty good utilization of some of the key tools, and that's great. Okay, that's getting you a good, solid understanding of what's going on in your equipment, in your assets. Now, again, the human inspections, and I think you said 81% of the people or the organizations are using that.
Mm-hmm. Mm-hmm.
Well, human inspection is great. Don't get me wrong. But we don't want to get to the point where we're relying on those. Unfortunately, by the time that a human can understand and to use their senses to detect a problem, quite often you're in the very tail end of a pending failure. And those of y'all who have been around rotating equipment, when you hear a bearing start to squeal or roar, don't plan on going home that night. Okay, and that's what we want to avoid.
Now, we do have one person here saying, shouldn't you just be using tribology as a reinforcing data set?
You can. Actually, I personally like it as a predictive tool, and the main reason is specifically on things like gearboxes and hydraulic systems. I have found them to be very beneficial. One
Fair
of the
enough.
biggest failures I've ever experienced was on a giant hydraulic press, and this thing had 4 cylinders that were about 20 feet long and about 4 foot diameter. Some big boys.
Ooh.
And each one of those to rebuild was about $70,000.
Yeah.
So we were actually able to identify, using the tribology, we were actually able to detect the seal failures before we actually could see it or even hear it with acoustical. And because of that, it gave us an opportunity to do the scheduled maintenance several months in advance, and we could take those down when we brought that unit down, pull them out, get the rebuilds, put them back in, and it didn't take the unit out of commission for the several weeks if it failed. It was basically out for about a week during a scheduled overhaul upgrade. So to me, I do consider it valuable, but it certainly can also be used as a support tool as well. And that's the key. These are tools that by themselves are not perfect. Our job as reliability people is to figure out that game plan for our specific types of assets and what's important. In some cases, acoustical and vibration may not be of any value to you. It depends on what your assets need. And that's where the reliability person comes in. And that's what we're going to talk about in just a minute. That's developing the game plan. So I would imagine that most everyone has heard of failure mode and effects. And we talked a little bit about that. And what that is that's an evaluation where you focus on the expectations of the asset or system, understanding what is its function, what is it supposed to do. It's my truck is supposed to get me out of that trout stream. And then understand the different failure modes. Well, if it breaks down and fails in the trout stream or down by the trout stream, very difficult for me to get out. It has an impact. But there's a lot of things that could cause that truck to break down, down in the middle of the woods. So we go through and we understand what the failures are, what the failure modes are, how those present themselves, if you will, through the different parts of the asset. And then we understand what is the risk. Because if you think about it, in a traditional safety or environmental world, when they talk about risk, it's the frequency of occurrence times the severity of the occurrence. But in reliability, we throw one other caveat to it, because if I can identify it, I'm not going to let it happen. And that's where we actually provide value to the organization. It's that next level of risk assessment and understanding. And then for those that have a very high risk, we figure out what the right thing to do is to put in place to prevent it, predict it, mitigate it, whatever the right situation is. As an example, my truck. If I don't keep good tires on it, I could blow a tire down on those rough roads. If it happens to me, is it that big a deal? Yeah, it's a little inconvenience. It'll torque me off pretty good. But imagine if my teenage daughter or my wife is driving that truck and has a blowout after dark. If that happens to me, yeah, it's a little inconvenience and it's irritating. Now, if it happens to my wife or daughter, that becomes a much greater risk because the impact could be much worse. So that's what we have to understand as we go forward under an FMEA type of analysis. It's understanding the failure modes of that asset or system, and what is truly the risk, and can we identify it?
So, Mike, I think your explanation of FMEA here is going to answer this question that came through, but I'm going to ask it anyhow.
Okay.
It's a pretty common one. So which defensive strategy would you apply first? Oil analysis or vibration, et cetera, like which is going to give you the earliest indication of a potential failure? And I bet you're going to say it depends on the failure mode, right?
Depends on the system, depends on the asset.
Mm-hmm.
Personally, in most cases, I'm going to go for vibration first. However, if it is a hydraulic system, vibration may not give me a whole lot. So it depends on my system. What is it that's really going to get me the bang for the buck?
Okay.
Hope that answered that question.
Yep. And then we have a much more specific FMEA question here, and you can choose to take it offline if you want, but it's what is the standard of conducting FMEA per ISO 6812 for the SO and D? Can we start off with the qualitative data approach?
Let's take that one off because I'm not exactly sure what you're asking me.
Fair enough. We will respond afterwards.
Yeah, we'll talk about it. If we can hold that till after the presentation so I can get a little bit better understanding.
Can do.
Sorry about that. Okay. And then as we go through the planning and the executing, reporting conclusions and updates, we are defining the criticality and the failure modes and what is the risk of those to our organization. Then we put in our control strategies. In some cases, that is those condition-based predictive type tools. That's our go-to in reliability if possible. Sometimes those can't identify things. We do have to look at failure finding. Example of, you test your smoke detectors once a year in October and change the battery, right? You're going to check and see if that's still functional. Now, sometimes you have to redesign it. Hopefully not, but it does pop up occasionally. If there's nothing we can do to mitigate it or identify it, and it is a major safety issue or environmental issue, then yeah, we need to really look at redesigning. Sometimes we do scheduled overhauls and PMs. I'm not a big fan of them because that puts you back in the infantile failure range, but sometimes that's what you have to do. As an example, if I have a centrifugal pump that's pumping a slurry, I may well know how fast that impeller is going to wear down to an unacceptable level, in which case I schedule to replace the impeller. Makes perfect sense. But we don't want to use those unless we have to. Sometimes there's nothing to, you just let her run till she fails. If it's not a real critical piece of equipment, it's not really important to you, yeah, that's perfectly adequate. Sometimes you have to pull it off and do an engineering evaluation. Maybe it's a very highly complex piece of equipment. So, and there's many, many more. These are just a few of them that look, but what you're trying to do is define those control strategies. And from a football standpoint, that is building that game plan, right? You're building your strategies of how you're going to prevent failure or mitigate it or predict it in your asset or your system.
Now I got a
So,
question for you.
yes.
For the FMEM, what's the best way to capture the results? And can you reuse the FMU or adjust it for other equipment?
Well, first off, the way I like to do it is I like to look at the as found risks, the
Mm-hmm.
frequency, severity, predictability.
Mm-hmm.
And then I look to see what do I expect to get once I have put in some improved strategies, if you will. I should see a reduction in that risk. And I like to plot those out and show the reduction in risk compared to the initial, and show that I don't have any truly high failure potentials because I'm attacking those with proper strategies and bringing down to a more acceptable risk level. And that, I think, answers the first part of the question. The second part of the question is, oh, heck yeah. If you have done one and you can steal from yourself shamelessly, by all means do. We don't want to spend unnecessary time, effort, and money. Now, you may have to modify it a little bit, don't get me wrong, but why reinvent the wheel? Okay.
Mm-hmm. I'm seeing some interest in that description you just gave about capturing the results, plotting out the reduction in risk. So if you happen to have an article or some tips on that on your website, we might want to point to that afterward.
Sure, be more than happy to.
Cool. Back to you.
Okay, thank you. So, okay, the other team scored. We had a failure. So what do? We want to run a root cause process, and it's basically a six-step process. Your notification. In other words, we've identified that we've had an occurrence of some kind. We want to go through and we want to understand what the impact is, what the data surrounding it, understanding the failure. Then we actually perform a root cause analysis. So you notice you do a few things before you actually do your root cause. Then you define your corrective actions. But probably the biggest failure is do we verify that the corrective actions actually do prevent reoccurrence or mitigate the reoccurrence? And then finally, documentation. Now, not going to go into a whole lot of detail on this, so I'm going to touch it kind of briefly. Some of the sources, you can have reliability engineers that are monitoring their equipment. They see repeat failures, they see pending failures, things like that. So understanding your data. Hopefully you don't have problems where someone out in the organization reports a problem. It could be a phone call, email, personal. It happens. It's not the best way. We want to operate off of a triggering system that looks at, tells us when we want to do a root cause. For instance, if it's a recordable or if it's a reportable release, something like that. If it is a high cost failure, if it's repeat failures, is it a truly critical piece of equipment? There's some pieces of equipment that it doesn't matter if it goes down for 5 minutes. I want to know why. So we define our triggers, if you will, that tells us to go do a root cause.
Do you have time for a question, or you want to keep going?
Sure, go ahead.
All right. Do you find that change management is key to a reliability program?
Absolutely. And we really haven't talked about change management. Now, there's a couple of ways that can be. I'll just make sure we're talking this thing. To me, change management is organizational change management where you're actually changing people. And
Or
that is,
changing processes, yeah.
or processes, yes. But yes, if we don't address the human side of that, I can pretty well tell you it's going to fail. That's absolutely critical. The other side of it, and I wasn't sure if this is what was actually being asked, is MOC, which is management of change, which is actually impact to your assets or your systems. You got to have both. So, and I didn't know exactly which way that question was going, so I answered both. How's that?
Okay. Hector, if you want to respond back with a more detailed question, you're welcome to, and Mike will follow up with you afterward.
Yep,
Mike,
good.
we got one other question that came in.
Okay.
And it's also on that human factor. And the question is, when you are preparing an RCA, who do you include on the team?
Well, excuse me. I would first off want to know anyone operational, maintenance, electrical, whatever, that was involved in it, because they're the eyes and the ears as to what happened. Probably want to have a maybe a subject matter expert, someone who knows that system best. In some cases, that is a system engineer. Sometimes it's a reliability engineer. Sometimes it's the OEM, depending upon what it is. But you want to have the key to it really is having a very good, well-defined, trained person who knows how to facilitate. Unfortunately, from a human standpoint, when you go into a root cause analysis, quite often people are nervous, something bad has happened, especially if there has been a culture within the organization that says, you know, anytime something goes wrong, we're on a witch hunt because, by gosh, we're going to find somebody to blame and it ain't going to be me. And so you have cultural issues. So probably the key to it is having that trained facilitator who can put people at ease, draw out the information necessary.
Cool. I'm going to hold a lot of the remaining questions until the end, just to make sure you have time to get through this. But
Sure.
Hector says that your answer on change management was perfect.
Okay, thank you. Very good. So the next thing is doing the root cause, and that's, many people say, well, what is the right tool? My argument is whichever one gets you what you need. And some of them are the fishbone diagrams, fault tree analysis, change analysis. I want to do the one that gets me the best information for what I need in a relatively timely manner, because some of these do take a long time. I don't want to use those unless I absolutely have to. Then we look again like at the corrective actions, just like we did for the FMEA. What are those corrective actions? Are they technically justifiable? You know, is there a situation where it's going to cost too much to do it? Am I going to spend $1 million to save a $10,000 failure? Probably not. But probably the biggest issue is the verification. You know, did our corrective actions accomplish what we tried to accomplish? Did they create some other unknown problems? Unfortunately, that does happen. We fix a problem, but boy, we made it worse down the line. Did we get the financial returns that we expected? And then got to have the proper documentation. And when you do that, one of the keys is that engineering change management or management of change, and this is not the human side, this is risk evaluation to ensure that changes that we put in our processes and in our systems do not create additional hazards. Okay, this is not change management, this is MOC management. Okay, and there's that continuous improvement for reliability that we looked at earlier. The FMEA, you know, the implement preventive maintenance and predictive tools. The check is analyzing CMMSs and root cause, and then finally corrective and preventive measures. That's how we get better. And then finally, winning and reliability feel good. There's nothing better than going out into a plant or any other type of process where everything's running nicely. I don't know about y'all, but boy, that makes me feel good. Okay. Questions?
And 2 points for anyone who can tell us who's on that photo that Mike just had on screen.
Anybody want to chat that one in?
All right,
Very
I'm gonna wait to
man.
see.
Very important man.
Indeed. Vince Lombardi. Good job.
There you go.
All right.
Okay.
Excellent. All right.
Question.
So, awesome job. And you're hired. You are welcome back on the show anytime, Mike. So, folks, you have Mike's email on the screen here, msmith@lce.com. And you've mentioned, Mike, that there are some tools on your site that are open for use. Is there one to help people take the next step after what you've talked about today?
Well, actually there is. And if y'all remember the very first part of this, I talked about what we call Atlas, and that's our intellectual property. And we have a section of that you can go to the website, go into Atlas, and this is not a charged thing or anything like that. And you can we have a self-assessment tool. And it helps you to see where your strengths and weaknesses are. Now, for those of y'all that said you were world class, probably not going to help you a whole lot. But for the others that are still trying to improve their reliability programs to get to world class, it's a good tool. It's free to use. There's also, you can go in and you can tour through the Atlas program to see what's in there. You know, it's one of those things where you get free access to a certain level. Then beyond that, there is some financial impact. But yeah, go to the LCE website and you'll see Atlas, and that would be the first thing I would do.
Right on. And folks, you are welcome to keep putting questions into the question tool. Again, Mike will get to them afterward if we don't have time to talk to him now. So use these last few moments to get those questions submitted. There's one that just came in, and this might be a follow-up afterward, but it's about cause mapping. Do you use that?
Yes, I do.
You want to talk about it just briefly?
Basically, in cause mapping, it's a root cause tool to try to understand, your cause and effective impacts, and use it all the time. I don't use it unless I have to use it. And the reason being is it's complex, it takes a lot of time, and maybe gross overkill for a lot of problems. Now, there are problems that you've got to go to that level, in which case that's when I would use it.
Excellent. And someone just put in the URL for that self-assessment. So I put that over into the chat where everyone can see it. I know that was very helpful. Thank you. Okay, so I have time for just one more question, and I think it kind of has to be, given the current situation where we got everything hitting us sideways, what's the biggest stumbling block for people?
I would say that the biggest issue, and because most people who are in the reliability and maintenance world are technical based people, it's ignoring the human side of it. If you don't address that organizational change management, anytime you try to take a change, you're going to have resistance, and resistance equals failure if you don't address it.
Yeah.
That would be my opinion.
Human resistance. Yep. Good one. If you will forward to the next slide.
Okie doke.
Even though we got Sweet Sorrows, this one's coming to the end. Next September 2nd, we have Sean Eisenhower from Erudicio on. And another East Coaster with a good drawl. Right, most of you are probably familiar with Sean. If you haven't heard him before, he's an excellent presenter and reliability trainer, and his topic is going to be what drives downtime and latent roots to reliability issues, right? So this is going to be a good one for moving past your sticking points. So please join us on September 2nd. And then if you'll move one slide forward again, this is a reminder to stay on after I close the webinar. There's going to be a slight pause and then the survey will pop up, and I'm really hoping that you can stay and answer the survey. We want to get your feedback on today's session. There'll be a question about what else would you like us to cover, and then if you do want a certificate of attendance, make sure to click yes and we will follow up with you. Now, everyone who attends will get a follow-up anyhow with a PDF of Mike's slides today. And again, you are welcome to ping Mike directly at his email. If you will forward one more, the recording of today's presentation is going to be up on excelix.com within a day or two. And Mike, thank you so much. This was fantastic.
Well, thank you. I thoroughly enjoyed it. I appreciate Fluke and inviting me to talk.
It was a great presentation, and I hope we'll see you
A
again.
lot of y'all's equipment, so at least I get to talk on your website.
Excellent. Right on. All right, so we'll talk to you again soon, and have a great day, everyone.
Thank you.
Bye-bye.